All right, together we're going to be adding rational expressions. Rational means that there's x on the bottom of one of the fractions, and adding means adding. Your job is to factor all of the denominators, make sure they're fully factored, get a common denominator by multiplying in any bottom piece that is missing from the others. Then you're going to add the two tops, keep the bottom the same just like you're adding regular fractions. Then expand and simplify the new top. Let's do it together a few times so you know what I mean. X minus 7 and x plus 2 are both already factored. There's nothing common to both that we can pull out, and so they're fully factored already. But this fraction is missing an x plus 2 on the bottom, so we have to multiply the top and bottom of it by x plus 2. I'm going to multiply that in there. I'm going to make sure I put brackets around the x minus 7 because I'm going to have to multiply those two later. Well, not really, but you'll see. And here I have x plus 2 on bottom, but I don't have an x minus 7, so I've got to multiply the top and bottom of it by x minus 7. I'm allowed to do this because multiplying the top and bottom of a fraction is the same as multiplying by anything over itself, which is 1. Put another way, the x minus 7s could cancel here, but we want to keep them because right now x minus 7 times x plus 2 and x plus 2 times x minus 7 are common denominators. They're the same thing. So our next line here is top plus top. That's 3 times x plus 2 plus x times x minus 7. And the bottom, which is common to both, is my new bottom. That's x minus 7 times x plus 2. Didn't matter which order those were in. Could have put the x plus 2 first, but that's fine. Now, we've now combined two separate fractions and added them to make a single fraction, although it does look ugly. I'm going to expand the top and then simplify it with you. Multiplying the 3 through the top here gives me 3x plus 6. And multiplying positive x through here gives me x squared minus 7x. My bottom is the same, x minus 7x plus 2. I like keeping my bottom factored. There's a reason for that once you get to calculus class, but I just like keeping the bottom factored. And then I collect my like terms on top, and I like putting them in descending order. I'm going to put x squared first. 3x minus 7x is minus 4x. And I have a plus 6. I already know this isn't going to factor because I don't know two numbers that multiply to positive 6 and add to negative 4. And my bottom is still x minus 7 times x plus 2. This is my simplified added rational expression. I made sure they were factored on bottom. Multiplied in anything that was missing from either to get a common denominator, then added the fractions top plus top, keep the bottom the same, simplify, and you end up with this. Now when you're doing rational expressions, your teacher's probably going to want you to state restrictions, and so I'm going to do that. Anything that ever appeared on bottom can't have been 0. X minus 7 can't have been 0, which is equivalent to x cannot be 7. And x plus 2 can't be 0 because you can't divide by 0. Whoops, didn't need that. Which means x can't be negative 2. So my final answer is this with these restrictions. Cool. Shall we do another example together? Yes. Remember to factor your bottoms first. Let's do that. I rigged these so that this bottom can be common factored, and this can factor by difference of squares. I can pull a 3 out of both of these, which gives me 3x minus 3. And I can factor, again, this one by difference of squares. That's x minus 3 and x plus 3. Now I got lucky here. I already have an x minus 3 in both of the fractions. It's already common. But this one is missing an extra 3 on bottom. I'm going to do this in a different color just to show you. I'm going to multiply this bottom by 3. Multiply that top by 3. Now I have that 3 on the bottom of both. And I need an x plus 3 over here. So I need to multiply this by x plus 3, and I'm going to multiply this by x plus 3. Is it clear that this bottom matches that bottom? I hope so, because they do match. Now I do top plus top. I have 4x plus 3 plus 6 times 3. You could have just made that 18 all at once. And I have 3 and an x minus 3 and an x plus 3 all on bottom. 3x minus 3x plus 3, 3x minus 3x plus 3. Cool. The common denominator is the denominator. Now we expand and simplify the top. It's going to take a couple steps here. I got 4x plus 12 plus 18, 3x minus 3x plus 3. I have 4x plus actually 30. 3x minus 3x plus 3. And then I can actually factor the top here. I end up with a common 2 getting pulled out of both. I'm left with a 2x plus 15 and a 3x minus 3x plus 3. If these two numbers had had something common to each of them, then I probably would have been able to reduce and cancel, but they don't, so I can't. Teachers are going to want you to state your restrictions. X can't be positive 3 or negative 3 here. Cool, there's my final answer. Do you like it? I like it. Let's just do one more. I rewrote the title on this one because I'm a fool, but don't forget to factor the bottoms first. Let's do it. My top is 2x. This factors by difference of squares. That's x minus 2 and x plus 2. This bottom does not factor anymore, so I'm just going to rewrite it for myself. And I can pull a common 7 out of the bottom of this one. That's 3x on top, 7, open bracket, x minus 2 on bottom. Divide both of those by 7, you're left with x minus 2. Now comes the work of getting the common denominator. I have an x minus 2 on bottom here. I am missing it here, so I will have to multiply it in. That's x minus 2 and x minus 2. I have an x plus 2 here and here, but I'm missing it here. So I have to add multiply in my x plus 2 here. And I have a 7 on bottom here that is not in either of these. So I'm going to have to multiply this by 7 and that by 7. Multiply that by 7 and that by 7. What a mess it looks like. But don't worry, we're on our way. I'm going to try to simplify this as I add it together. This first term is just 14x, top plus top. I have 49 here that gets multiplied into that bracket. That's 49x, and times negative 2 gives me negative 98. Here I have a 3x that's being multiplied into my x plus 2. That gives me a positive 3x squared and a minus 6x. The whole bottom of this is that extra 7 and an x minus 2 and an x plus 2. See, they all had the 7, they all had the x minus 2, they all had the x plus 2 because the denominators were common. Yes. Simplify the top by collecting like terms. I have a 3x squared. 14x plus 49 is 63. Minus 5 is plus 57x. That's not going to factor. And minus 98. Cool. All over 7, open bracket, x minus 2, x plus 2. That's all I can do. This probably doesn't factor. I don't know two numbers that multiply to 194 and add to 57. And state restrictions, x can't be 2 or negative 2. Cool, there's your simplified thing. But I hope that these 3 examples have just pushed you through and emphasized that it's easy to add rational expressions. Step 1, factor all your bottoms, like factor your denominators. Get a common denominator. Add your fractions just like regular fractions, that's top plus top, and keep the bottom the same. Expand and simplify your top. Sometimes it will refactor. If it does, you should do that. Best of luck.